So the first thing you'll have on your test is just simplifying expressions using the numbers. Okay. So in this case, we have the 6th root of 64 to the 4th power. Remember, you can kind of do what you want in the calculator, and the order doesn't matter technically to get the answer. My advice is to apply the index before you apply the exponent. The 6th root of 64 is 2. And then I'm going to apply the exponent. And that's going to be 16. And that's the order I would go in each time. When you have a coefficient on the outside, it stays on the outside. What is the cube root of -8? When you take the cube root or an odd root of a number that's negative, it's negative. Okay? You take an even root, we can't take the even root of that negative number without imaginary numbers. But if you take an odd root, the answer can be negative. The cube root of -8 is -2. Okay? And this answer ends up being -8. Because then you multiply the 4 through there as well. When it's put in fraction form, the denominator is the index. The exponent is the numerator. And once again, I'm a big fan of taking the index and then the exponent. The 5th root of 243 is 3. And then 3 to the 4th is 81. When you're given a negative exponent, okay, I can't stress this enough. Negative exponent, you deal with it first by making the exponent positive, which means you move your base. The negative exponent means you're going to the denominator. And now we're doing the 6th root of 64 to the 5th. The 6th root of 64 is 2, and 2 to the 5th is 32. So this answer is going to be 1 over 32. I cannot stress that enough. A negative exponent results in movement across the fraction bar. So when you raise something to the negative exponent, you got to put it in the denominator and then you apply it. Your answer is not negative. Negative exponent does not mean your answer is negative. It represents movement. Here, the 5th root of -32 is -2 to the 4th. -2 to the 4th is a positive 16. And then 3 times 16 is 48. We don't apply this outside number till the exponent's been dealt with. And finally, the cube root of -8 to the 5th. The cube root of -8 is -2 to the 5th. -2 to the 5th is -32. So the first one's pretty straightforward. We have the same base, which means when we multiply, we're adding exponents. Okay? Same base of 4 means my answer is going to be 4 to the something. Now, how do I add my exponents? 5 over 2 plus 3/4. I've got to get a common denominator. If I multiply the top and the bottom by 2 over 2, I get to 10/4 plus 3/4, which is 13/4. Okay? And my answer is going to be 4 to the 13 over 4. There's nothing else you can do with that. Like if you could take the 4th root of 4 and then you had a number you're going to reasonably raise to the 13th power, then you do it. You got to kind of make a good decision here. There's nothing you may do with 13/4. Now, if you want to write this answer as 4 to the 4th root of 4 to the 13, that's fine too. It's up to you. Okay, I will accept the fractional exponent. In most cases, that's how the answer will go. Now, the second one, Nothing I can do with the bases here to make them similar right now. Okay? But what I can do is I can distribute the exponent. 3/5 times 5 is 3, so I get 5 cubed. 6 to the 5/10, okay? And that could be reduced to 1/2. My advice, you can do something with this. 5 cubed times 6 to the 1/2 is this. 5 cubed is 125. 6 to the 1/2 is the square root of 6. You can write the answer that way. Now, would I accept you leaving it like that? Yes, I would. Yes, I would. Okay. I'm going to be pretty liberal in how I grade this in terms of as long as you've done some manipulation and you leave me with an answer that's mathematically correct, so be it. Okay. But we should know 6 to the 1/2. If anything raised to the 1/2 is square root. 5 cubed is 125. That's not out of the realm of being able to do that. Now we have the same base. When we divide, we're subtracting. 7/8 minus 5/6. I'm going to multiply the top by 3/3. I'm going to multiply the left by 3/3. I'm going to multiply the right by 4/4. And we're going to be left with 21/24 minus 20/24, which is 1/24. Once again, there's not much you can do with that. So my answer here is 5 to the 1/24. That's the answer. Finally, when you have different bases, and notice, you can't even make these bases the same. You can't write 24 as 2 raised to something. There's really not much you can do that. But when you have the same exponents, what you can do is take the bases out, like this, and put the exponent over here. Because in this case, it's the same deal. It'd be like distributing the 3/4 to the exponent of 24 and 4. You can do that. Okay? Now let's reduce here. 24/4 reduces to 6. And 3/4 times 4 reduces to 3. And 6 cubed is 216. If you left it as 6 cubed, I'd live with it. Okay, when you have the same index, you can multiply. 16 times 4 is 64. And it's the 5th root. If you can simplify it, you should do so. 2 and 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2. I see 5 2's here, so that can go on the outside. So this becomes 2, 5th root of 2. We didn't do a great job of this on our quiz. 4 times 3, 12. Root 10 times root 5, 50. Now, if you can simplify the radical, you must do so. 2 and 25, 5 and 5. So I have a pair of 5s that go on the outside. So this is 12 times 5 root 2. 12 times 5 is 60. Root 2 is our answer. Okay? Now I can multiply the 12 to the number outside it. You have to simplify radicals. You have to be in the habit of simplifying radicals. Same deal with the second one. You can simplify that 12 first if you wanted to. I think it's easier. 4 times 3 is 12. 12 times 5 is 60. To just simplify at the end for radicals. Now, if you notice, once again, the numbers outside the radical get multiplied. The numbers inside the radical get multiplied. And then root 60 can be simplified. 2 and 30, 2 and 15, 3 and 5. I have a pair of 2's, and I have a 3 and a 5. 12 times 2 root 15. The 3 times 5 get multiplied and put back under the radical. 12 times 2 is 24. And we get 24 root 15. And our last one, same radical we can divide. 4th root of 32. And if you can simplify it, you must do so. 2 and 16, 2 and 8, 2 and 4, 2 and 2. The number that appears 4 times goes outside the radical. The number that appears an extra time goes inside the radical. I probably should box that right there as well. Those are our answers. When you have the radical in the denominator like this, multiply by the conjugate, which is essentially what's ever in the denominator with the opposite sign. The top is just distribution. 5 times 4 is 20. 5 times negative root 3 is 5 minus root 3. The bottom is foiling. 4 times 4 is 16. Minus 4 root 3 plus 4 root 3. And then root 3 times a negative root 3 is minus 3. And the middle terms will always cancel. So this answer is 20 minus 5 root 3. With these canceling, 16 minus 3 is 13. We have to leave the denominator as one number. Same deal on this one. We're just multiplying by the conjugate. Was that denominator with the middle sign switched? You're basically creating a difference of 2 squares. This is automatic. Now on the top, you're foiling. 6 times 5 is 30. 6 times root 6 is 6 root 6. Root 2 times 5 is 5 root 2. And root 2 times root 6 is root 12. 5 times 5 is 25. Plus 5 root 6 minus 5 root 6 minus 6. Root 6 times root 6 is 6. Okay. Now on this one, I can simplify that 12. I wouldn't take off and get into it. But it is good to always have things in the simplest form. So that numerator really should look like this. And it's going to be long, and that's okay. Don't ever worry about that being like a long number. Here, the middle terms cancel, and 25 minus 6 is 19. And that's our answer.